Hello, in this video we're going to discuss how decision trees actually split data. How do they decide what variable to use and where to do the split? Well, the technique is actually quite simple. It's an exhaustive search. So let's take a look at the iris data set again. So if you look here, you can see that we have 150 different iris flowers, and we have 3 different species, the virginica, the versicolor, and the setosa. So we have these 3 different iris plants, and we want to decide how we can differentiate, given the sepal length, the sepal width, the petal length, and the petal width. How can we differentiate between these various species? So what the decision tree will do is he will start off with all of the records in one node, and then the decision tree will start off with the first variable, in this case, the sepal length. And the decision tree will sort this data and then will split at different points and find the best way to split the data on the sepal length, and then say, okay, that's the best sepal length split. Then it will move on over to the sepal width, and then it will move over to the petal length and then the petal width. And it's going to find the best split of all 4 of these. Once it does that, it's going to then say, who's the winner here? And that will be the split. Let me give you an example so that you can see how this is done. We'll start off with the sepal length. So what we will do is we'll start off and we're going to sort by the sepal length. So let's go over here in Excel and sort by the sepal length. So there you go. So it's sorted it from smallest to largest. So let's just copy these guys over temporarily. And what we're about to do here, the decision tree software will do for us a lot faster. But we're going to do part of this in Excel just to see how the process works. So we're going to first look at sepal length. So let's get rid of these guys right here. We don't need them. So let's just delete those. So now we have the sepal length and the species. So let's go and grab those. And I have another tab, and we're just going to, I've already pasted them, but we'll paste them again. There they are. So I have all that data that I just had, and I've copied it, and I've got a bunch of other stuff right here that is derived. I'm doing all the calculations in this Excel spreadsheet that a decision tree will be doing for us. Let's start off by splitting on, so now we see that the decision tree has all of the data of our sepal length, and it has been sorted from smallest to largest. So we could say, what if we split this on this first record? In other words, 4.3 and 4.4. So in other words, a split right here, halfway point is 435. So let's take a quick look at that. So if we look at that first row and we split at 4.35, one of the records will go into one side of the decision tree, and everybody else goes on the other side. So at that point, how good is that split? Well, what happens is the decision tree has a metric or a measurement of how good of a split that is. And there's a lot of them out there. Most of the time, people will use the Gini index. There's an entropy index. There's a chi-square distribution. There's all sorts of different measurements to say how good is this split. Gini just happens to be the one a lot of people use because it's easy to calculate. Let's not worry about what the mathematical formula is. The decision tree knows how to calculate that. All we know is we want a small value, the smallest possible. So if we were to split this thing at 4.35, one record goes over here. So in other words, we're going to say sepal length 4.35. One record goes here, everybody else goes here. We've got a 6622 score. Is that good? Well, I don't know. Let's find out. Let's look at another one. So what if we split it? We've got a bunch of guys who have a 4.4, and then over here is a 4.5. So let's now say that we want to split between these two groups. Okay, so that would be row 4. So let's put row 4 in here. And you can see that the Gini score got lower. So this is a better split. So if I say that all the people who have a 4.45 sepal length, look at that, it's perfect. They're all 4 of them are setoses, and it's a better score. All the rest are over here. So then the decision tree is going to go, okay, let's try make this a little bit, something else. So then he'll move down here between, let's say, 4.6 and 4.7. So let's try that. So that would be around row 9. So let's try that guy. So now it's even gotten smaller. And look, they're all setoses. This really looks like it's a great variable to split on. So we could keep doing this. And eventually, just by brute force, the decision tree will keep increasing this thing. And let's come down here to, I don't know. Let's come down to between 5 and 4, 9, and 5. So that would be row 22. Now the number dropped from 6.2 to 5.8. So it's a really good split. But now we're starting to miss a few. Because look, now we've got some versicolor and virginicas in there. So it's not perfect, but boy, it's a pretty good split. And if we try this even further and we come down here to I don't know, down here around 5.35, let's try that guy, row 46. Let's try that. So we put 46 in there. And look, that thing goes even lower still. And then it's we end up with 40 of them. We still are missing a few of them. And let's try a few more. I don't know, let's try 5.58. Let's try 58. So by row 58, if we do that, look, a split at 5.5, again, we've got a better Gini score. We're missing a few of them, but we are getting most of the setoses. So what will happen is the decision tree is going to continue searching for the best possible split. And I'm going to speed this process up. So I tried a few of those with the computer shut off, and it looks like this is probably the best split as far as the sepal length goes. Now let's go and ask the R programming language what it considers to be the best split. So if we do this, let's just load this guy in. And we're going to say, now we're only going to tell R to go 1 level deep. We want to find out what the best split is here. So if I were to say, let's go 1 level deep. Now let's say that we're going to tell R that we're going to look at the sepal length. And the sepal length here is, we're going to say split the species up and only use the sepal length. So let's do that. Let's copy that and see what R considers to be the best split. And it says that the best split is at 5.5, which is where we found it to be. And it says, look, I can get 35% of the data, and I've got 87% of these people are setoses. So this is based upon, if I look at only the sepal length of the flower, I can do a pretty good job at splitting this. What is the metric that we have is a score of 0.4439. So let's just score that over here. So sepal length is 4439. And that is the sepal length. Perfect. So we now know that that's the best one to split on for the sepal length, but that's not where we stop. So now we go back here to our data set, and now we look at the next variable, sepal width. Let's sort by that. So we go over here. Now the computer does this at lightning speed. We're doing this by hand. Decision trees were not really practical years ago, but now that computers are a lot faster, this is a much more realistic approach to doing data science. So let's copy these guys over here. Let's paste it. And we don't want the sepal length anymore. We don't want the petal length, and we don't want the petal width. Let's just delete those guys. Let's copy these two guys over here and paste them in here. There we go. So now let's see how good this one is at splitting the data. So let's start off at 1. And you know, we can see that this one here, how good is it differentiating between one species and another? Well, we can see that the versicolor is at 2.1. Now it's splitting out the versicolors. And if we look over here, we can see that we look for some natural splits in the data, and we can come down here till, I don't know, row 19. Let's see how good that one is. So row 19, the number is lower, and you can see that we're doing a better job. You know, we've got a lot of versicolors in there. So I'm going to stop the recording and see if I can do a brute force search to see where the optimal split is. So we'll be back in just a moment. And I'm back, and I found that it seems to me like the best split would be around row 113. So look at this, it's 0.63, and if I go to 113, the split is at 3.35, and I've got a really nice score here. And you can see that this is a really good at splitting out. The setosas seem to be over here, and the other guys are over here, and I've got a nice Gini score. So let's call that 5397. So .5397, and we should probably put what the split is. The split was 5.5 for the first guy. Whoops. And this guy here is at Whoops. Is at 3.35. Okay, now we can do the same thing for the petal length and the petal width. So we'll do those. Let's just, well, let's first of all see what R says. Okay, so if I go over here and I'm going to now build another decision tree, and I'm going to say, okay, sepal width this time. So let's do that. And let's see if I mean, I did all of mine by, you know, eyeballing the data. Let's see if, look at that, he has 3.4, and the sepal width is this, and so he had 3.4, but I think it rounded it up to 1 decimal place. But see, you can see that the sepal width is around where we thought it would be. So let's try the other two real fast. Let's just go back over here to the data, and this time we'll look at the petal length. So let's sort by that. And let's copy the data. Let's paste it in here. And we don't need that, or that. Let's delete those. And whoops. I think I got too many rows or too many columns. There they are. Okay, so let's copy these two guys over here. And just eyeballing the data right down the path, it seems to be a perfect split right here. Look at that. There's nothing. So if I were to draw, well, if we just draw the line like at 1, the setosa, you can see I could just keep increasing the row. And they all are setosas until I get to like row 51. Look at that. So at 2.45, it's a perfect split. Look at the Gini score, 0.3333. So let's just put that guy over there. So the petal length is at 2.45. And it's 0.3333. And what was it, 2.45? Yep, 2.45. And let's see what R has to say. So let's go over here and look at the petal length. And there it is, 2 point, what rounded it. But again, perfect split on petal length. We can try one last time. And let's go over here to the petal width. Let's sort that guy one time. Sort petal width. Let's copy that and that. Put it over here into, well, heck, we don't even have to do that. We just paste it right in. Paste. Look at that. Okay, so let's go over here and you can see we've got, 1, 2, 3. It keeps dumping them all into the setosas. If I go down to row 50, look at that. It's a perfect match. This is another perfect split. The petal width is also perfect at 0.08. So, so we can do 0.8. It's another one, 0.3333. Petal width. There you go. Now, if I were to sort these, let's sort them by the Gini score. There we have it. So these two guys both have the same score. We didn't check to make sure that that's the right split. Let's find out. So this one is going to choose the species based upon the petal width. And again, 0.8, look at that, perfect match. So you can look at this. Now the decision tree software is going to say, I can choose this guy or this guy. They're both the same. How is it going to choose? It's going to be either a random selection. There's going to be some software decision as to a tie. This is why when you're using software, let's say you're using R or SAS or Python, you might get different decision trees. They'll all have roughly the same accuracy, but you can get different decision trees that are all really close to one another in accuracy. That's the nice thing about decision trees, is they are very robust. Even if you get some slight differences, they all end up to be roughly the same. They have a lot of similarities into what they consider to be the appropriate variables, and they'll have the similar accuracies. Let's just see if I were to do this split, for the first split, the decision tree, one of these two guys will be the winner, either the petal length or the petal width. Let's find out what R thinks. So now at this point, I'm going to look at the full tree, and instead of just using one variable, I'm going to use all of them. Sepals of the species, and I'm going to have the sepal length, and then you put a plus sign, the sepal width, plus sign, the petal length, plus sign, and the petal width. And we're only going to go one level down, okay? So if we only go one level down, now incidentally, in case you're curious, if you've got thousands of variables, you don't have to write all 1,000 records. You can just put a dot there, and R is going to be smart enough to know to use all of the records or all the columns. So, but we're going to just, for clarity, we're going to use this. And we're only going to go one level deep, and we're going to ask R, what do you think the best split is? Now, R is going to run 4 different decision trees, and then he's going to say which one is the best, and that'll be his split. So if we do that, look at that. He decided on petal length, which is where we were. Remember, we said one of these two is going to win, and R has decided, for whatever reason, that this is the best split right here. And that's the decision tree. Now, the interesting thing is, at this point, R is done with setosas. But then R is going to follow the exact same process right here for this. So if I were to say, let's go 2 levels down, I could do that, and we'll see what we get. So let's say if we take this 2 levels down, see, the decision tree is going to follow that same process right here. And there you go. So I just said we're going to go 2 levels down, and now we're going to run another decision tree with all of the variables, and then we're going to print it out. And this is what we get. We start off with 33% of these were setosas, 33% were virginicas, and 33% were versicolor. Those are the 3 iris species. We split on the petal length, and we got a perfect setosa. So we know that if I don't know anything about my flower other than its petal length, I can tell if it's a setosa or not. Come over here, and we've got our versicolors. Now it splits on the petal width. And you can see that it does a really good job of deciding if it is a versicolor or a virginica. So at this point, if I look at the petal width, I can know if this thing is, it says a small petal, it's going to be a versicolor, and if it's got a larger petal, it's going to be a virginica. So with 2 questions, I can differentiate what species of flower I have. Do I have a setosa, a versicolor, or a virginica iris? So that's the process that decision trees go through. It's a brute force trial and error, and it finds all of the best splits, and then it lets them compete amongst one another. And then it keeps going until it at some point it stops. So anyways, that is decision trees and how they work.